So, hello everyone. Good morning. This is the session on intelligent manufacturing systems, session number 4. And I'm chairing this session. I'm Dr. Ahmad Barari with uh, Larissa, Dr. Larissa uh,
Yes,
Driemeier, correct, Larissa? Yeah,
Driemeier.
Driemeier, sorry. So I let you continue introducing yourself, Larissa.
Uh, Hello, everyone. Welcome. My name is Larissa from University of São Paulo. I am here to co-chair and help Professor Barari. And welcome. Okay.
Thank you. So we can start short videos of all the presentation, following with questions from audience, and the presenters will be available to answer the questions. Thank you. Please start the presentations. Yeah.
My name is Mizael Falheiro, and I'm one of the authors of this work. CAD software tools employed in a reverse engineer application, a fun propeller model reconstruction. This work is based on a literature review of a reverse engineer process and works, and it's proposed a methodology for the reconstruction of CAD model from a STL file, where the STL file is obtained by scan process. The CAD model reconstruction is divided into three main steps. They are treatment of the STL file. The second one is the creation of reference entities, and the last one is the creation of the CAD model. In this work, it was used a damaged fan propeller as a physical model. After scan, the point process was performed. As I said, the first stage of the CAD model reconstruction is the treatment of the STL file. After the treatment of the STL file, curves and other entities can be extracted from the STL file, and these entities can be used to create solid and surface. Here is a surface generated from an STL file, and here it's a solid generated from curves that were extracted from an STL file. CAD software tools presented this work are powerful and can make the design process faster and more accurate. And the methodology presented here is independent of any specific software packed as they were presented in a generic way.
Thanks for watching our presentation. My name is Ricardo Pasquati Fontaroli, and I will present our article towards security mechanisms for an industrial microservice-oriented architecture. When we talk about service-oriented architecture, and we call this presentation SOA, we can see that we have the migration from the traditional architecture used in the industry. In the figure represented by a pyramid, where we have hierarchical levels, to this new architecture based on a cloud. In this new architecture, all equipment, systems, and resources are in the same cloud infrastructure, enabling interoperability and system distribution. When we talk about distributed services, they represent a piece of software with some functionality that communication with another services to compose an application. In this article, we use the microservice-oriented architecture, which we call MOA, which is an aspect of SOA, but in a more granular way. This is the industrial pilot plant where we performed our tests using the MOA architecture and safety tests. It has 4 control variables. This first architecture has no security mechanisms and was used in the industrial plant. The data acquisition DAC microservice is responsible for the data acquisition sensors and update outputs actuators. And the PNID control microservice control the process variable available in the industrial plant. It also receives controller inputs, parameters, such as the controller gain. An external application was developed within LabVIEW for the orchestration of the microservices to control the pilot plant process. In this case, the 18 steps in each orchestration cycle are done, as you can see in the figure 4. The transporter service used for communication was the High Performance Message System, NAT, in orange hexagon. The API Gateway Service, green hexagon, was used for communication between the external application and the microservices. All the services are responsible for the composition of microservices for a control loop with the MOA architecture. We enable one mechanism at a time to see its impact on the total control time, where without any secondary mechanism we got 62 milliseconds, and with all mechanisms enabled, 228 milliseconds, represents a significant increase, but still performing the control normally. If you have any question, please contact us.
That was a video demonstration made for a combative student project at Ontario Tech University in collaboration with 82M Laboratories. Here shown is the SOLIDWORKS 3D model along with the full built prototype. The physical prototype consists of 4 main sections. The chute design that is actuated using a servo to dispense snow in the desired direction, an auger mechanism powered by a DC motor to propel the snow out of the chute, the chassis that contains 4 sim motors that each power an individual wheel, and finally, a platform for all the electrical components. The robot uses the Robot Operating System, known as ROS, to integrate the many software and hardware tools together. This includes the motors, encoders, Arduino, camera, and this is to work together in order to develop the 3D mapping of the area it drives in, which is seen in the 2 images on the left. The Internet of Things IoT was used to create an open weather map API to get the robot's location and look ahead at a 5-day weather forecast in 3-hour intervals. It looks at the current day's snow volume, time, and temperature to determine when the robot should proceed with clearing the driveway. Both a flow diagram and an example of the API can be seen on the left.
Hello everyone, my name is Adelson Duarte dos Santos. I am a PhD student at UNESP. I will briefly present the subject of my work. This work proposes an autonomous energy wireless sensor node for monitoring the motor condition using its dissipated heat as energy source. Why is this important? An autonomous energy sensor can replace battery-powered devices. Also, the collected data can be used to predict the motor's behavior. We attached the thermoelectric generator to the motor fins for capturing its dissipated heat as energy source. We evaluated the DC-DC conversion efficiency. Finally, we evaluate the energy consumption of the sensor node working every 5 minutes. This was our setup. What you can observe in the photo: a 350 watt single-phase induction motor, the thermoelectric generator TEG, the power management circuit, the breadboard with 3v3 linear regulator, supercapacitors and accelerometer, and MCU CC1310 from Texas Instruments. What we achieved: we harvested 3.90 milliwatts from environment, and we delivered 893 microwatts to the sensor node. This ratio results in an efficiency of 28%. The energy consumption during data acquisition and transmission represents approximately 27% of the total available energy. The remaining energy can be used to transmit other parameters such as temperature. Retransmissions can be done. And finally, the dead cycle can be greater than 0.15%. In this work, we presented a proposal of autonomous energy wireless sensor powered by the thermoelectric energy harvesting generator. We estimated that the temperature difference of 3 degrees Celsius were capable to maintain sensor node operating every 5 minutes. The sensor consumption was around 27% of the total available energy. The collected data can provide a maintenance schedule program with low impact in plant operation. This work was supported by FAPESP and TechPlus through the PIPE program. There are the references of this presentation. Thanks for watching.
Saudações a todos, meu nome é Kevin Rabelo e vou apresentar o trabalho intitulado Sistema de Monitoramento e Gerenciamento para Unidades com Geração Distribuída, baseado no protocolo MQTT. Bem, inicialmente é interessante a gente falar sobre a geração distribuída, né? Ela foi instituída no Brasil através da RN número 482 de 2012 e, entre outras coisas, foi estabelecido, né, um sistema de compensação de energia. Né? Esse sistema de compensação, do jeito que ele está hoje, ele é perfeito para fins de faturamento, mas ele deixa o consumidor incapacitado, né, impossibilitado de saber o seu consumo e a sua geração real através da fatura de energia. Visando, né, solucionar esse problema, esse trabalho apresenta, né, propõe um sistema de monitoramento e gerenciamento para essas unidades. Então, a figura 2, ela apresenta uma visão macro do sistema proposto. Então, basicamente, eu tenho medidores inteligentes que foram desenvolvidos e cada medidor ele é composto aí por um módulo de medição PISEN 004T que envia, né, essas informações via comunicação serial para o módulo ESP32. O ESP32 ele tem a capacidade também de comandar, né, um módulo relé que realiza o acionamento das cargas. Bem, as medições elas são enviadas através do protocolo MQTT, através de um broker, né? Esse broker ele proporciona uma isolação entre as medições, né, entre os dispositivos conectados e a aplicação web. Essa, por sua vez, armazena os dados no banco de dados e apresenta ao usuário esses dados em gráficos atualizados em tempo real. Então, a figura 4 ela apresenta a arquitetura do sistema proposto. Basicamente, são previstos 2 medidores, um para consumo e um outro para geração, sendo esse último aí acrescido do módulo, né, relé para o acionamento das cargas. Bem, com o trabalho, né, foi possível ter um controle em tempo real de quanto que é consumido e quanto que é gerado, né? Foi visto que a precisão do sistema ela, está de acordo, né, com o que era esperado, sendo possível a comparação com os dados da concessionária. Por fim, né, foi visto que é possível a utilização desses sistemas não somente para medição de consumo e geração, mas também para uma medição setorial aí de consumo, ou mesmo para o consumo, medição de consumo individual de cada equipamento. Então, basicamente é isso. Agradeço a todos.
Meu nome é Luana. Eu gostaria de apresentar a minha proposta de um agente autônomo utilizando as técnicas de mineração de processos em uma arquitetura virtual baseada em sistemas multiagentes. Esse artigo teve colaboração também do professor Dr. Percy, do professor Dr. Osvaldo e do professor Dr. Francisco. Nós somos pesquisadores do Instituto Federal de Educação, Ciência e Tecnologia de São Paulo. A ideia desse trabalho de pesquisa é apresentar uma proposta de arquitetura para a utilização de um agente autônomo que aplica os conceitos de mineração de processos, que ele é capaz de compreender a sequência de processos, de identificar possíveis pontos de interrupções, predizer problemas, recomendar medidas e agilizar processos. Então, esse agente utilizará os dados reais para alimentar modelos de simulação que estarão virtualizados. Para atender esse objetivo da proposta de pesquisa e também que seja aderente à arquitetura distribuída que a RAMI 4.0 propõe, a ideia é, então, utilizar uma arquitetura em 3 camadas, onde eu vou ter, nessa arquitetura, um agente minerador de processo, que estará em um ambiente virtual integrado com o mundo real, através do conceito do CPPS. Esse agente ele irá coletar os dados do processo real através do sistema de supervisão e controle, que é o software SCADA, que é super conhecido e utilizado no mercado, e do gerenciador de conhecimento. O agente gerenciador de conhecimento ele possui informações de engenharia e de produção, que estão vindos, que são provenientes da base de conhecimento que estará no processo físico real. Então, alocado no ambiente virtual, e também utilizando o sistema multiagente, o agente minerador de processos irá processar os registros de eventos recebidos, aplicando as técnicas de inteligência propostas pela mineração de processos, e enviará sugestões de ações, se necessárias, para os agentes de mediadores de recursos e de transporte e para os sistemas de supervisão e controle, que é o responsável, então, pelo processo de operação em tempo de execução. A pesquisa ela ainda está em fase de desenvolvimento dos modelos, aplicados a um estudo de caso para posterior validação da arquitetura e do conceito do agente minerador de processos.
Are you mute?
Yes, sorry. Thank you. Yeah, always it happens. We had 6 good presentations today, 6 different topics, but we saw the trace of intelligence in all of them, like applications of developing intelligent systems. There are some questions already in the chat box, but we can start adding to the list of questions, and I wish to invite each one of the authors to answer to the questions now. What I suggest as the from the host, if you can let people in, like all the authors, maybe they can join the room, and then they are available to have a chat here. Thank you very much. So I guess I will start with the paper number 1. For the first 4 papers, I can handle it, but for the last 2 papers, Dr. Driemeier, I wish you to
Yes.
contribute more. Okay. So from Michael with the paper on CAD systems, I can start with a question, but if the audience also have questions, please let me know. Um, the question originally, one question was from Professor Eduardo about the application of your system, and if what you can produce here as a CAD model can be used for 3D printing.
Yes, once the CAD model is reconstructed, it's easily convert it into a STL file. And once it is converted, we can import it in a slice software and print it.
Okay.
Okay.
Once this model it was reconstructed from it was converted from a CAD model, a solid model. The STL file maybe won't present any fail or inaccuracies.
Michael, I have a Mizael. Sorry, I keep saying Michael, but it's Mizael.
No problem.
So I have a question for you. Like, if you already have a STL file is a direct input to your 3D printer. You don't even need the CAD model.
Yes, but when you use a 3D scanner or photogrammetry process, we have to convert the point cloud into a STL file, all right? But this STL file will present a lot of inaccuracies and fails.
Beautiful.
So
Yes, exactly. So you do this CAD process in between for a little filtration to remove the errors and smooth the surface. So you will do a smoothing as well here. You produce
yes,
smooth surface.
yes, yes. We use the initial STL file as a reference. Construct a CAD model solid, and from that convert it into another good STL file.
Okay.
Uh,
That's
uh, I think I have a question similar to Professor Barari. You talked about treatment of STL in the first step.
Yes.
Is it manual? I mean, you go part by part to make this treatment, isn't it?
Okay. Depending of the CAD soft CAD package. Some tools are totally automatic, and other software tools is manual. In this case, I use manual tools in order to fix some part, because when I fix some part of the initial STL file, it becomes easy to use this as a reference in order to construct the CAD model. But
Yeah.
some free and commercials software package, they offer us total automatic tools that we can use to reduce the number of faces, eliminate rules, and so on.
Okay, great. Thank you.
Thanks. So, Mizael, how long the process takes for this impeller to manually adjust the points?
Could you repeat, Professor Barari, please?
Yes.
Sorry.
How long? How long did you spend time the amount of time that you spend for this process.
All right. As this process was some part manually, the time is compared to another old process, automatic process. It take a bit of time because the treatment of the stat file was totally manual, and the reconstruction of the CAD model was total manual too, right? So compared with other process that involves manual process, it's I think we can consider that this process is very, very efficient, all right? But when we compare with another tool, another algorithm that can make this work totally automatic, I think there is a few disadvantage about it.
What is the CAD software? What CAD software did you use?
I use the NX package, right? Because it's one of the most complete package when we talk about reverse engineer tools, right? When we talking about reverse engineer tools in the industry, the NX software is one of the main package available.
Do you are you aware of any programming language that you can write some algorithm as a routine, subroutine inside NX?
NX, I don't know, Fusion 360. I think it's possible. NX, I've never worked with the API in NX. I don't know if it's possible to program routine to automate for automatization of process and the CAD model design in NX. All right, Physics 360 is a software that I have experience. It's possible to do some automatic reverse engineer application in that.
Perfect. Thank you. Thank you very much.
Thank you.
So we can switch to second paper now. There is any question for paper number 2, please? You can ask. I can ask with the basic questions that I wish to know. What is the definition of microservice? How do you compare just a microservice with a regular service? Like what's the special here in that you call it micro?
Okay, that's actually a good question. I'm not from the computer science. I'm more from the automation science. But in our research, the microservice is about the granular. This is like the size of the service. So we can put several different functionalities inside this service. So the idea is to be micro, is to be as simple as possible. So we can reply, we can reuse this microservice in another applications. So that is the main idea between regular service and a microservice. Of course, that we can have like a regular service as a microservice, but the idea is to be as simple as possible, like implementing just a few functionalities, specific functionalities. For example, we can have like a service, a control service, but if you think as a PID algorithm, we can have a PID microservice. So control service will be fuzzy or PID or any other kind of control algorithm. And a PID microservice is a specific service of control. So that's an idea.
Well, that was a very good example, though, like you just clarified to me. But do you think the service, for continuing on your example, the PID microservice also is more simple than regular PID, or it is going to be the same PID quality?
Okay, of course that we have to consider the network, because a microservice or a service-oriented architecture is a networked architecture. So it's not only about developing a control algorithm, a regular control algorithm, or the discrete control algorithm. So we have to consider the network impact on the control system. So in this PID microservice, we are using a specific kind of control algorithm. There is the PID plus. It's a known algorithm for network applications. So we just, how can I say, adjust the PID plus in order to use this algorithm in service-oriented architecture. So we are now deploying the PID plus algorithm as a service.
That's nice. Still, I'm curious to know, like, if someone chooses to use microservice PID here, for example, do we lose quality or efficiency at all, or it has the same quality and efficiency of the regular service?
I don't know if I can answer that, because we didn't compare like our microservice, the performance of our microservice with other kind of control algorithms. So I can just say that our algorithm, it's okay. We can control our process, our plants without any problem. We are looking for performance parameters as how fast we can implement a control mesh with this microservice-oriented architecture and this kind of thing. We didn't compare like control performance of different algorithms.
Interesting. What are few applications in your mind for the future development? Like, if people want to utilize this for the other applications, what do you suggest?
Are you asking about the microservice application?
Yes.
Okay. So if we consider the Industry 4 or the Industrial Internet of Things, we are facing different technologies like information technologies in the industry. So the main one is like cloud computing functionalities used in industry. So for example, if you think like in a controller today, we'll think like in a physical controller, like a PLC or a DCS or any other kind of controller. So for example, using our microservice PID, we can make like redundancy of controllers in cloud, like using service. So if I replicate one service, create the other instance of the same service, it's automatically, I already have redundancy of controllers. This is one example of this kind of application in industry. We can cite another ones, but we can reuse of all the service. We have automatic network communication. If I create a service, this service will be available to be used by any other service or application in the network. So all of this network communication is automatic. I don't need to implement code for network communication. So we have a lot of advantages of using service-oriented architectures in the industry.
Very interesting. So it's like little tools are available that you can plug to your application, basically service tools that you can just plug and play with.
Yeah.
Thank you very much.
I have one question. It's not my area, so maybe it's very simple one. But you are talking about security.
Yes.
Why it's so? Of course, it's important, but it seemed to me that you are more concerned about security using microservice. Is it right? I mean, when comparing with SOA, I think that you call it a traditional way.
Okay. When we think about security in industry, it's always important. It's hard to think in real application, real industrial application without security. So there is a lot of security mechanisms that we can use in network applications, like traditional network applications. But this kind of security mechanisms are not automatically applied in service-oriented architecture or microservice-oriented architecture. So in our paper, we researched about traditional. We didn't develop any new security mechanism, but we deployed some available in the literature, and we evaluated the performance of the system of using this security mechanism in our architecture. So the idea is, we have different levels of security in our system, according to the experiments that we are presenting in the paper. In your application, you can select like the minimum security or even the maximum application. And our results show that even with the maximum level of security, we can still apply our system in regular control systems using the microservice-oriented architecture. Like the control time, the speed of each one of the control meshes is faster than the required times that we use in process control systems.
Oh, okay, clear. Thank you.
Thank you very much. Any other question for Professor Eduardo? No, thank you. Thank you very much, Professor. So we switch to paper number 3 now. The first question that we have already in the chat is from Professor Eduardo. I am a co-author of that paper, but I let Tristan, which is the first author, and he's here, he answer.
Yeah.
So the question is, yes, perfect. How did you estimate the minimal power consumption of the Snowblower?
Yeah, so the idea was to use the IoT system to automatically turn on and off the system. And the idea is that using IoT, you'd be able to check weather reports. And based on tests we would do, it would calculate what the optimum time is to go plow the snow that would result in the minimum amount of power consumption. As going when there's too little snow, it wouldn't provide much benefit. It would have to go out too many times. But going when there'd be too much snow, it would cause too much strain on the system, causing that additional use of power. As for the actual measurements, this was a student project, and by the time we started to get the prototype running and testing, There was no snow available at the time, so we haven't been able to finish testing for that. But the idea was to calculate that optimum power usage based on the amount of snow. It would also have to depend on the different types of snow, whether it being light snow or packing snow. And that's how the minimum consumption would be measured.
Nice. What I suggest, Tristan, considering the audience that are from Brazil, most of them are from Brazil now.
Yeah.
So I don't know how much experience you have with the snow, like a snow blowing. So this is the important thing to explain, right? So for a snow, when the snow falls, at the moment, if you plow right away, it doesn't consume that much power. But if you let this snow, for example, get frozen, like just say at 10 p.m. at night, you had a snowfall, and if you just do a snow blowing right after that, is less energy needed, even if you are doing manually. But assume that about 5 a.m. the temperature goes down below the freezing point and it gets frozen. Then the same job can consume 1,000 times more effort. Right? So it becomes very difficult. So the idea here is this machine communicate with the weathercast, so it knows what's going to happen in the next few hours. So if the temperature is really going down or not, or if more snow is coming, basically. So based on the information, it can decide when is the best time to do the job, to minimize the consumption of energy.
Yeah.
One of the very bad scenarios, in my opinion, is if the snow comes and then there will be a rain after that, so it just get melted. So there is water there, and then it froze, and then temperature goes down for freezing. Then you have a problem. In this aspect, like just the concept in design was just to minimizing energy usage by using the information.
Okay.
Just to
Okay,
kind
thank
of
you.
to that. Sorry, the snow is can kind of be compared to sand in some respects. Like if you have a little bit of sand, it's easier to push, but once you build up of a lot of sand, then it would be very difficult to push. Or if the sand were to get wet, then it becomes a lot heavier as well. So snow is similar in that regard. But that's just addition to what Dr. Barari said.
That's a good point. Yes. So
Yes.
the energy is not, the energy consumption is not linear comparing to the volume of the snow. Probably is non-linear, correct? So for the little snow is very easy, but as soon as it just increases, then it becomes very difficult.
And I imagine that you have a maximum, there is a maximum height that you can use your machine. And is it programmed? I mean, most of snows you have, you can use your machine, because probably sometimes when it snows a lot, it's impossible to use, isn't it?
That's a good
So
question.
yes, very good. So the idea would be that it's constantly taking in weather data on intervals, normally like something like 15 minutes. And what it does is it sees the estimated precipitation amount that's coming over the next few hours, and it determines, okay, once it hits this precipitation value of, say, 10 millimeters, then it would send the robot out to clean the snow before it gets to a level that would be too much. And the idea that it would go out and with a minimal amount of snow so that it can clean it quickly and then come back to its station, then it can charge, and then it can be prepared to go out again once that value reaches that threshold again. That way it's constantly keeping up with the snowfall and not letting it build up to the point where it can no longer plow it.
Oh, okay. So you don't have problems to put your machine in the snow. Of course, in a acceptable level of snow. Yeah.
I mean, I think this, Tristan, sorry for interrupting you, but you can add to. I think this question and previous questions basically are the main reasons that intelligence is needed here. Correct? So number one was the previous question about finding an algorithm or a solution that minimizes the use of energy. So it needs to look at the weather and say, okay, when is the right time to do it? For this question also, the idea is because it's a robot, it's autonomous, and it just continuously can work. So it should plan in a way that it never allow too much snow on the ground. So always the wheels can even touch the ground. It doesn't let the snow to cover because it's just dynamically working. Even in this project started last year. So Tristan and his group, they finished one version, but they have a phase 2 now. Another team, still Tristan is going to advise them to continue. But one of the ideas is even make the machine even smaller, but use this intelligent and consider algorithms that even 2 of them or 3 of them are working simultaneously. Looking at the weather condition, they may need support. So the small gadgets are working in your driveway dynamically to clean up.
Okay, and in this intelligence is predefined the region where you need to clean. I mean, you go out with a predefined way.
So that probably you can add more, like about the vision system, detection of the problem, and the location. What is your setup for that, Tris?
Yeah, so what you'd have to do is initially you'd have to have the robot go around the area to define the map of your driveway, and then it's able to reuse that map each time it goes around the area again. And then it uses, in our case, visual odometry using a camera, a stereo camera, that can then detect any objects in the way. That's using the ROS operating system.
Yeah. Great, that part of ROS. I love it. I love it, your video.
Thank you. There's another question. Is this battery powered? Yes, it is. Uses a 12 volt, 18 amp hour SLA battery.
And there is a charging station. Right? So it just goes, charge itself, and then continue. So this is also part of the game to know when is the right time for charging. Comparing all these parameters like the amount of snow that is coming, forecast information, the height of the snow on the ground, and then power available. So it needs to really decide what's the best scenario.
Yeah.
And may I ask another question?
Sure.
I didn't read the paper, so I don't know if you are already doing that. But are you guys planning of using any kind of like a vision system or even a sensor to measure the amount of snow before doing the task? Because you can do the forecast. Okay, this is a good time to do the plow, but when you go to the site, there is a forecast mistake, for example. So if you measure the amount of snow, now I decide to not doing right now and do after 1 hour. I don't know. Because if your idea is to maximizing or minimizing the energy consumption, I think that that will be another task that you can do.
Mm-hmm. Mm-hmm.
Yeah, that's a good question. And we did talk about it as a team. Unfortunately, we didn't have time to actually get to figure out how to implement something like that. But it is something that Dr. Barari did mention to us that we wanted to take a look at implementing. That way, you can have your predicted precipitation and then match it up with an actual, and then you can determine if it is truly the best time to go. But we haven't gone to implementing anything like that as of yet.
So that was also a very good question. I think what is happening right now, we don't have a sensor on the machine right now, but the concept is some sort of, we call it digital twin, that gets this information about the forecast as accurate as possible, and it just simulates what is the condition of the snow. So it knows, okay, if this is the snow information for the past few minutes, and then comparing the path that was already cleaned, it should be able to roughly estimate how much snow should be on the ground. But as you said, there is a possibility for error and mistake because the forecast information is not 100% accurate. So there will be some errors. So if the sensor that you are mentioning get added to the system, then this estimation can be adjusted based on the real data. Right? So a sensor that capture data and then adjust the information.
One last question, because you are using Jetson Nano, aren't you? We are beginning to use in a work we are doing, and my question is, because I know Raspberry Pi and Raspberry Pico, for example, are you using Jetson Nano for a choice, or it's really better in
Sorry, was the question like, do we use Jetson Nano by choice?
Yes, yes. Yeah,
Yeah,
we are
so
having a lot of problems with the setup and all these stuffs.
Mm-hmm.
yeah, one of the other members ended up having a Jetson Nano, and that was just what we went with for cost saving, and we found some success using it. It was a little bit difficult to set up initially, like you said, but we were able to successfully get it working. I wasn't too much on working with the Jetson Nano, but yeah, I can't really speak too much to it.
Okay, no problems.
So maybe
It's,
the right answer is no, because just it was available, correct? So that
Yeah,
yes.
that was our choice also, because we have available a Jetson Nano. So
yeah.
Yeah, it is a good problem. This snow removal machine, and there are a lot of details. If you want to get really into something intelligent and efficient, there are a lot of details that needs to be solved here. So we just, I think we just had the version 1 so far. There are some future works needed now. So thank you, Tristan.
Thank you.
Um, we can, I guess, switch to next paper now, paper number 4. Um, I start with a question from Professor Eduardo for the paper number 4, and that's about the ratio between the average power required for solution operation and the harvested energy. So the question
Okay.
Yes.
Yeah, the average power rating is 30%. We can achieve the 30% of average ratio power.
So 30% is achieved. Oh, you mentioned 28%, I guess, in the, is that the
Yeah,
same? Yes.
yeah, because in the paper I mentioned related to energy, and it's around 27%,
Mm-hmm.
28, depends on the motor situation.
Okay. Mm-hmm. Mm-hmm. So I want to build on this question, ask another detailed question that says you have 28% or 30% for how much watt?
Sorry,
As you said, it's for 3 watt or what? Like this 28% is for the current energy.
yeah.
If the energy itself is double, what will be the efficiency? Do you think efficiency is going to remain linear or it's going to be very nonlinear?
We not evaluated in our work the efficiency of the harvested energy compared to the sensor consumption.
Mhm, mhm. So at this time, 28% is not bad. So basically, you're almost one third of energy is recovered, correct? Harvested.
Yeah,
But if you want to go for something that other applications with a stronger levels of energy, for example, for the cars, so you want to attach it to the car wheels and then collect energy from them. It's interesting to know how the efficiency will be for the stronger cases.
yeah. I agree with you. And we evaluated just in the motor pin that we have in our laboratory. And the main idea is to transmit low package. For example, accelerometer axis or temperature, because they are they are the characteristics that you can use to see how the motor is working, if it's good or bad. Because the idea is the filtration method to evaluate these these motors
Hmm.
these motors conditions. So if you need to transmit a lot of data, maybe you need to switch the energy harvesting technique. Maybe a solar or other one that are more efficient than the thermoelectric, because the thermoelectric is, efficiency, né, is around 10%. It's very low.
Hmm. Very interesting. Any other question on this paper from audience?
Yes, I have another one. Which kind of sensor network are you guys looking for in this project?
Yeah, we thought that we can use the mesh network, but in this paper we evaluate just one node, just a node, a sensor node, But the idea for future works is to expand to a mesh network.
But are you guys using any protocol, any standard, or?
Yeah, we were using the sub 1 gigahertz. Then it is inside of ESM bandwidth.
Okay.
I have a question. Why a thermal sensor? I mean, it's much more efficient than, for example, piezoelectric or something like this.
Because the TG, the thermoelectric generator, is the thermoelectric generator have a low efficiency for itself.
A low efficiency.
Yeah. The thermoelectric generator,
Okay.
when you put a heat flow on the thermoelectric generator, the output voltage is very low compared to the heat flow that pass through the TEG. So the application of the TEG must be a ultra low power consumption, because the TEG efficiency of the TEG, the conversion of the thermal energy to the electricity is very low for itself.
Okay.
Thank you
Thank you.
for the questions and your answers. At this time, I think we can switch to paper number 5. If Dr. Driemeier, you can lead this question.
Okay. I saw in the comments in the chat that Kevin told that despite the presentation being in Portuguese, the questions can be carried out in English. Yes.
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 Respect to our colleagues.
Yes. So I let's see if there is any question in the chat. No. Okay, I have a question for you. Can you explain better your that part that you showed? You call it smart meter. What do you have there inside?
Okay.
Because outside that is only data organization. Yes.
Yes, sure.
Okay.
Just to summarize, our work is a monitoring and management system for distributed generation units, for units with this distributed generation. So we did a smart meter, and inside this meter we have a ESP32 microcontroller. It have native Wi-Fi module. That's why we use it. And beside that, we have a meter that is Pizane 004, and a relay module that controls some loads in the house. So we used two of these meters, one for measure the generation and the other for consumption, in order to have the all the energy management for the unit. That's because after
After
install the the system, the solar system, for example, the user uh, don't don't see anymore the real energy consumption of his unit.
Yeah, it's a very interesting work, and uh, if I want to install it in my house, for example, how much more or less it will cost in terms of install it and in terms of maintenance?
So that's a trick question, really, because first of all, we have to see if it's a monophase unit or a three-phase
Okay,
unit. It
okay,
depends. So,
sure.
and if you look only for the equipment costs, it will have a cost of $100 for the three-phase system. Uh, and for the monophase system is about 40 or $50. So that's only looking for the equipment costs, of course. That
Okay,
if you turn this in a project, you have to some costs, of course.
okay. Any more questions?
I look now.
Please.
Now that I'm learning more, I like to understand about MQTT. Is it as far as I search on Google? It's a messaging mechanism for IoT. Am I right? Yes.
Yeah, sure. The MQTT is a tool very used for IoT, um, because it's a lightweight protocol. The header is really tiny, uh, and the other parts also. That's because it's using the IoT applications.
Perfect. So, what is the frequency of the messages? Like how much? What is the frequency? Maybe in hertz amount of data that needs to be transferred in these messages.
So I I don't I don't know exactly how the frequency is, to be honest.
Mhm.
But yes, I'm sorry, I don't know answer this question.
Well, the reason that I'm asking because we are looking for some applications now for the IoT base, but it's about the vibration. So vibration sensor, it gets the data of the structure and needs to be transferred somewhere else. So that frequency of the vibration is very high. So a lot of data points need to be communicated. Uh, so I like to know like if MQTT can work for something like that when you have like 5,000 hertz as your frequency uh, for the vibration, or is too much for this?
Yes, sure. Today we have this concern about the frequency, of course, but I think the MQTT is allowed to operate in the major part of the countries.
Mm.
Um, yeah. Okay.
Thank you.
Did you validate your results? I mean, comparing, I think I saw something like this in your presentation. You validated your results and compared with the, I mean, did you implement it already and compared with the values you receive from the,
Uh,
yeah.
yes. We installed this. Uh, we installed two prototypes in our laboratory, but besides that, we did precision tests. We compared the smart meter results with a multimeter in order to validate the precision of the system.
Okay. Okay. Thank you. No more questions.
Thank you very much.
Thank you.
Thank you so much.
I think we can now switch for the last presentation. Sorry, Luana, em inglês ou em português?
Eu prefiro em português, se puder.
So I am sorry to Professor Barari and Dr. Tristan. A Luana, alguém tem alguma pergunta para a Luana? Se não tiver, eu posso começar com uma pergunta. Deixa eu ver, eu anotei aqui. Luana, você pode me dar você pode me explicar melhor? Desculpa, eu não sou da área de 4.0. Então, você pode me explicar melhor o que é o RAM 4.0 que você falou?
É uma arquitetura. É uma arquitetura que, na verdade, é uma proposta, né, de mudar a arquitetura que a gente tem hoje, da ISA 95, que é uma arquitetura hierárquica, para uma arquitetura distribuída. E uma delas é a RAM 4.0, que, né, é uma proposta.
Tá, entendi. Você tem algum exemplo de caso, por exemplo, que eu possa... Porque você falou que o trabalho ainda está em evolução, né?
Isso. É porque, na verdade, o foco do meu trabalho é no agente minerador de processos, né?
Isso.
Então, para ele estar dentro de uma arquitetura, ele precisa estar numa arquitetura distribuída para atender os requisitos da indústria 4.0. Por isso, a sugestão da RAMI, né? Do uso da RAMI.
Entendi. Porque eu queria entender melhor a ideia desse agente minerador que você fala.
Na verdade, a ideia é o seguinte, a gente olhar para o processo, né? Então, hoje, eu tenho os dados de processos de tempo real, né? A minha ideia é que, normalmente, as empresas utilizam o sistema de supervisão e controle, já é um software consolidado, só que eu não consigo tirar a inteligência desse processo, né, da maneira, até para gerir e olhar para o contexto em relação à quantidade de dados que esses softwares normalmente geram. Então, a ideia é colocar esses dados na nuvem, né, então esse agente minerador de processo receberia esses dados históricos, então quer dizer, eu tenho a história do que aconteceu no meu processo, e dentro dele ele aplica os algoritmos, né, porque a ideia do minerador de processos é ele usar as técnicas de inteligência artificial, machine learning, e as facilidades para eu olhar para essa grande quantidade de dados. E aí, ali dentro, eu quero, né, tirar, dentro da mineração de processos, eu tenho algumas etapas, por exemplo, descobrir o modelo, né, desse processo, eu posso também usar algoritmos para inferir, de repente, algum insight para melhorar aquele processo. Então, a ideia é essa, e se eu tiver algum insight, eu retorno isso para o processo, né, para o processo real, poderia retornar isso no insight, para o próprio software SCADA, por exemplo.
Tá. Tem uma pergunta no site, aqui nos comentários, quais são os paradigmas usados com o MAS? Você está modelando o processo de interação ou o raciocínio para os agentes?
Exatamente, é o raciocínio para os agentes. Nesse momento, o foco da pesquisa é no agente inteligente mesmo, que é o minerador de processo.
Certo. Deixa eu ver, mais alguma questão? Professor Eduardo, por favor.
Eu tenho uma. Luana, vocês estão pensando em alocar esse agente em qual das camadas do RAM? Acredito que em uma das camadas de TI, né?
Isso.
E vocês estão pensando em utilizar qual mecanismo de comunicação, qual protocolo para fazer implementar essa funcionalidade?
Sim, na verdade, a proposta era usar o publish e subscribe, né, para conversar entre os multi-agentes, até por conta de ter esse dinamismo na arquitetura, tá? Inclusive, eu estou usando já uma arquitetura que foi modelada e já foi testada por um outro colega do grupo de pesquisa, né? Então, até por isso da escolha desse forma de comunicação.
Mas qual das camadas está pensando em alocar esse agente? Você já tem alguma ideia disso ou não?
Não, ainda não. Na verdade, o que eu quero, por enquanto, é fazer uma simulação, né? Então, está numa camada mais de simulação antes de retornar isso para o processo real.
Tá bom.
A gente tem uma pergunta aqui. Você fala em representar o SCADA, porém SCADA é ISA 95. Como você pretende resolver isso?
Não, na verdade, eu vou coletar os dados do SCADA, né? Para usar os dados dentro da mineração de processos, eu preciso olhar para os eventos que são armazenados pelo SCADA, né? Então, o SCADA, ele gera ele guarda os dados em uma base relacional. De lá, eu posso exportar esses dados para o CSV, e aí sim, dentro do agente, eu consigo olhar para esses dados.
Ok.
Nice. I believe you already asked the questions in the chat box, correct? There are 2 questions about.
Yes, I just mentioned them. I think we finished the questions. Do you have any question, Professor Ahmad?
No, I think it's done great with the questions.
Maybe a last question here. Você não acredita que o agente deveria olhar para a representação do SCADA?
Eu não entendi. Representação em qual sentido?
Representação em qual sentido? Bom, eu acho que tem o seu contato, né, no seu trabalho, e se alguém tiver alguma dúvida, pode continuar, pode conversar.
Claro.
I think we can close now, Professor Barari.
Sure. Thank you very much. There is one comment here also for Kevin from Mr. Fernando Luis Marcelo Antonos. Considering the acquisition of large number of components, the cost of the system presented by Kevin would cost more or less, correct? So it depends on the size of the company.
Yes, sure. Professor Fernando is my tutor, and I would like to say thank you for him. So yes, increasing the number of the components, the costs become less expensive.
Yeah, sure.
Perfect. Thank you very much. I think we had a very good session this morning with, again, different topics, but interesting applications in intelligence and IoT. Basically, combination of different tools that can be used in this system. Like, I think very informative. It was very informative for us. Thank you, everyone. If there is no other comment or question, I think we can dismiss the session now.
Okay, thank you.
Thank you.
Thank you.